The future of frameworks, presented by Alclim Yakut. When I was in high school in Panama, there was no easy and accessible way to code. Even more challenging was a professor that could teach me how to follow the most accessible and the correct protocols. Even though frameworks already existed, developing countries such as Panama did not teach young students on how to follow the appropriate way of making a program in the most efficient way. Following a framework for developing a program these days is almost non-negotiable. According to the importance of software engineering published by CAST, software engineering is important because a specific software is needed in almost every industry, in every business, and for every function. It becomes more important as time goes on. If something breaks in within your application portfolio, a quick, efficient, and effective fix needs to be implemented as soon as possible. End quotation. Therefore, software engineering is as important as the development team, business teams, and even short of the CEO in some IT or software companies. Most companies and developers, and even freelancers, follow a framework to have a structured guideline when building a program. Yet, as new technologies emerge and the revolution of technology keeps creating new languages and reaching all kinds of people who previously did not have access to code, the need for evolution or creation of new frameworks is necessary. 2 decades ago, the Agile Manifesto, one of the most recent ones, was published for public use. Until today, most frameworks created follow a similar pattern. Most frameworks have a pre-development analysis phase, a development phase, modeling phase, a fixing phase, the debugging phase, and a maintenance phase. Considering the above mentioned, it should be no surprise that management teams will begin to evolve current frameworks in the coming years, implementing less cost-effective frameworks and enhancing efficiency by automatizing some of the processes. Also, the implementation of new high-level modeling languages in current frameworks make it easier for end users to test programs in development and even provide direct feedback, even in some cases fixing the problem, and implementation of new framework that uses computational intelligence as a primary driver for automatizing and creating even higher level abstraction layers with the use of machine learning and visual media processing across all phases. In the next 5 years, the current software engineering frameworks will likely still exist, but in an enhanced way. Existing frameworks such as Agile and Waterfall will probably continue to be around for the next couple of years due to the abstraction of dealing with software. Also, considering that these frameworks are relatively new, for example, Agile has only been for around 2 decades, there's no need for creating a new framework at the time of this being recorded. For example, but there is though room for improvement in both of frameworks. For example, Waterfall might become less expensive in earlier phases by implementing algorithms that follow similar projects, therefore making tests more efficient and less cost effective. Also, there might be new implementations for testing and debugging phases, but nothing groundbreaking. Consequently, I do not consider that any new framework will emerge. Yet the current ones will probably be upgraded in terms of cost efficiency, time consumed, and organization quality for at least the next 5 to 10 years. After 10 years, current frameworks will probably evolve and be combined into a more united and flexible framework. New frameworks will likely begin to emerge after 10 years of analysis, testing, and unions of current ones. To increase efficiency during the development and modeling phases, one thing that could be done is designing a high-level modeling language that can be automatically compiled into executable code. According to Tevfik Bulton, we should develop high-level modeling languages that can be automatically compiled into executable code. In other words, making a framework that already exists, that already consists of policies and high-level abstractions that multiple working teams can begin working on without compromising the quality of the code. Also, making it possible for end users to provide feedback and enhance the code via high-level abstractions quickly would evolve the current era of developers to a more advanced stage. Currently, there are many software developers and computer scientists. Still, there is not nearly enough to analyze all the data provided by data banks or databases needed to create such a high-level framework. In other areas, using visual media to process framework processes, such as how an app should act, could help developers get a more concise idea on how to implement every iteration. According to Ming Shen et al., in intelligent visual media processing, when graphic meets vision, visualization is intended to lead the viewer the important details of such depiction. For example, providing an automated algorithm to developers that self-actualizes the current priorities of the iterations in a visual representation of how the client or manager expects the app to behave. Furthermore, having frameworks automated for end users and even implementing a visual depiction for them to critique or give feedback could give valuable information for testing among diverse networks. Finally, with artificial intelligence or computational intelligence, software engineering in 50 years may shift entirely to machines. First, let me introduce you to artificial intelligence or computational intelligence. According to David Poole, artificial intelligence is the study of the design of intelligent agents. An agent is something that acts in an environment. It does something. And quotation, pull it out. In other words, it's a study of how software can act in a humanly intelligent way to solve or react to any subject in the outside world. Having said this, the automatization of software development can help software engineering by creating new high-level abstraction layers. As it is known, software coding is one, if not the most crucial part of the development of the software development phase. Implementing a systematic way of adding abstraction layers would make it easier, faster, and more efficient for software developers across a team to interact with coding. For example, imagine a software engineering framework that automatizes most of the coding and development, leaving just human developers to review and debug any program issues. Plus, humans tend to make more mistakes than humans. That's a fact. Therefore, having machines do most of the work where mistakes are commonly made by humans will significantly reduce the time implemented on each phase of the development. Human moderation will still be needed across all development phases, yet with artificial intelligence automatization, machines will be making a significant amount, if not most, of problem solving and coding, leaving it to humans' work that is less mistake prone. In contrast to my experience, nowadays high school and even elementary students have access in developing countries to multiple teaching resources on developing and implementing programs using standard frameworks available, such as Waterfall or Agile. As new technologies emerge, current frameworks will continue to be updated to increase efficiency. Also, machine learning will probably be one of the main tools used for automatizing current pre-development, development, and maintenance phases. Furthermore, people who are not experts in the field should be able to help across all those phases with the addition of high-level abstraction layers and high-level modeling. In conclusion, the future of software engineering will begin by evolving the current frameworks. With a lot of time and hard work, new frameworks will allow more manageable and more understandable coding across multiple teams, platforms, and networks. Thank you.